Absolute deviation. Now, absolute deviation is an application of what we're dealing with here, and I'm going to abbreviate. Absolute deviation is the absolute value of the difference between x and a given value. Now, what does that actually mean? So we're going to use the next example to try to figure that out. Number 2, you are buying a new computer. The table of values show the prices of computers in a store advertisement. You are willing to pay the mean price with an absolute deviation of at most $100. How many of the computer prices meet your condition? So we have all of our computer prices over here, and you're willing to pay within essentially a certain range of prices for the computer that you want. So it says you are willing to pay the mean price. Let's start there. Remember, mean is an average. And the way we find an average is we add all the numbers and then we divide by how many there are. So how many numbers? Okay, in order to do this, I'm going to first add up. I'm going to start with this column. I'm going to grab my calculator and I'm going to add up all of these numbers. So if I add up 890, 650, 660, etc., that gets me 3,375. Then I'm going to go to my next column. I'm going to add up these. So if I add up 750, 370, etc., I get 3,265. And then I have to add them all. So now I'm going to add up these two, which is going to give me 6,640. So that's add up all my numbers. But then I have to divide by how many numbers there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which gets me $664. Okay, so let's go back and see what we're dealing with here. You are willing to pay the mean price. Okay, so we're willing to pay $664 for this computer with an absolute deviation of at most $100. So what that's saying, if we just think about it, it's saying, okay, you're willing to pay $664 and then either more than $100, so more than that by $100, or less than that by $100. That's what we're talking about when we're talking about absolute deviation. It's kind of like a range of values. How much, I've heard the word tolerance used. What's your tolerance? How much can you go above your value? How much can you go below your value? So if we just think about this, if the mean price is $664 and you're willing to pay $100 more, well, that means at most you're willing to pay $764. If the mean price is $664 and you're willing to pay $100 below that price, then you're willing to pay $564. So then how many of the computer prices meet your condition? Well, then you would just be looking over here for which of the computers are between $564 and $764. So let's see, you would be willing to pay $650. You would be willing to pay $660. This one's too low. This you'd be willing to pay $725. $750. This one's too low. $670, $650, and that one's too high. So 1, 2, 3, 4, 5, 6. How many of the computer prices meet your condition? 6 of them. Now, how does that actual equation of absolute deviation come into this? So what it would look like algebraically to get this answer, because essentially you just got it, is you would say, okay, well, I'm going to do the absolute deviation between what I'm willing to pay and 664, which is my mean. And then I want that deviation to be less than or equal to $100. So the distance between what I'm willing to pay and the mean has to be less than or equal to 100. I don't want to go above 100. I don't want to go below 100. I want to be somewhere in that $100 range. So if we were to solve this, we would have x minus 664 is less than or equal to 100. Or we would have x minus 664 is greater than or equal to negative 100. On the first one, if we add 664, we would have x is less than or equal to $764. If we added 664, we would have x is greater than or equal to, 564. So if we took a look at that on a number line, I could put 564. I could put, this is a really rough number line, 764. So my value has to be less than or equal to 764. Or greater than or equal to 564, which means we would be willing to pay for a computer anything between those price ranges, which is what we already found over there.